Hello and welcome to a buildingSMART webinar. This webinar is hosted by the buildingSMART regulatory domain and is part of a series of open house sessions planned to occur in between the biannual buildingSMART summits. Thank you for joining. My name is Sheila Karai-Lum and I will be your moderator today. Today's webinar is titled, How can openBIM help with compliance in infrastructure? Our speakers are Dr. Ruben McDonald and Nicholas Nisbet. This webinar is scheduled to last 1 to 1.5 hours and with a short Q&A at the end. The webinar is being recorded and will be made available in due course. Before I hand over to our speakers, I would like to remind you that your lines will remain muted for the duration of the presentations. If you do have any questions or wish to make comments, please use the chat function located within the control panel. I would also like to bring your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent. And standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. Please take note of our antitrust code of conduct, which is on the screen now. And with that, I would like to hand over to Nicholas to start the presentations.
Okay, welcome everyone. Welcome to this open house. The theme of today is indeed infrastructure, and looking at the needs of the infrastructure sector for regulatory and requirements compliance. With a view to making sure that the buildingSMART standards, including IFC 4.3, meet those requirements. We're hoping that Ruben McDonald will join us shortly. He is Director of Systems Safety, Security and Interoperability at HS2. And we've asked him to talk to the theme of those regulations and requirements. And then we will, I'll say a few words about how the regulatory domain might address the points raised. Just to describe the way that the regulatory domain works, it's one of about 10 domains that buildingSMART International uses to link between different sectors and interest groups and the development of the standards. And so the regulatory domain sits alongside the construction domain and probably, yes, the product domain, as looking at the process aspects. And then we have a number of domains that look at different facility types, including infrastructure, rail, airports, ports and harbors, and starting soon, things like high voltage electricity and those sorts of things. So this is an opportunity to discover the issues and also to think about how we might respond. We are seeing the rollout of automated compliance checking for buildings in several countries, Dubai and Singapore this year, Finland and Estonia early next year. And a lot of the regulatory domain has, over the last 10, 15 years, focused on the building domain, where the requirements and expectations and the administrative arrangements are a lot clearer and exposed and published. And so I think and indeed the focus of the IFC was always was initially on buildings. with the launch of IFC 4.3, we can now emphasize that buildingSMART and the IFC standards and all the supporting standards are equally applicable to infrastructure. I think currently the only major emission is tunnels, which will be included this year. But the main entities, objects, and the geotechnical model are part of IFC 4.3, which was adopted by ISO on the first days of January this year. And so we have the buildingSMART Summit in Valencia next month, and we will be launching on the as a general support for the industry, a guidance for regulators on openBIM. And this is a document which we hope we can use to reach out to regulators and to people interested to understand how openBIM solves many of the anxieties about proprietary formats that regulators and governments have, and to understand some of the stepwise processes that regulators can go through on the way to adopting or benefiting from automated compliance. We will also be launching a information requirements document, several documents, but on the theme of regulatory information requirements. We've been speaking to many of the countries that I've already mentioned, and also looking at UK practice and so on, and identifying what the common themes are, especially around fire, accessibility, and energy and sustainability. And we will be publishing the set of additional properties or attributes that people around the world might want to include in their models as a step towards supporting regulatory compliance using open standards. There will, although not direct responsibility of the regulatory domain, I'm also involved with the sustainability. It's called a strategic group. It's a cross-domain working party, and we will be publishing the recommendations for what information should be in a facility model, whether it's infrastructure or building, to support the assessment of sustainability. That will be published in a format called IDS, Information Delivery Specification, which is a format that can be checked against models systematically. And so it takes the idea from ISO 19650 of information requirements and makes them machine readable. They can be presented as documents if necessary, but the most important thing is that any deliverable can be checked. And so for the sustainability aspect, we are going to publish, in fact, 3 IDSs, one for information about a facility, 2 information about products and materials, and a 3rd IDS, which will identify what information should be in the environmental declarations that are currently being used and demanded in Europe, in the UK, and also in North America and probably across the world. So we're moving ahead on many different fronts. Sheila, could you just give me a nod if Ruben has joined us?
He hasn't as of yet, no.
Okay. Ruben's having some difficulties connecting. So what I'm going to do is going to skip his slot, and maybe we'll end up tackling this problem the wrong way round. But I'd just like to say a few words about the difference between building and infrastructure regulations and requirements. Yeah. Hang on, I lost something. Let's go back here. Okay, well, this is probably repeating what I've just covered. As I say, in Valencia, we will be releasing the guidance for regulators on the use of openBIM. Why openBIM helps regulatory processes, the current state of openBIM, and more generally, the role of data and standards, and some thoughts about change management. And by openBIM, we now tend to use that phrase for all the buildingSMART standards, which includes the IFC, the schema, the interoperability schema, often seen as a file format, but it can be other things too. But also the IDS that I've mentioned, and other standards that support the processes in our industry. As part of that, we have been looking at the global case for automatic compliance checking. The automated compliance checking should and is delivering accuracy, completeness, and efficiency. The accuracy is important because we want to make sure that the automated compliance is doing what our other manual processes have been doing, hopefully better, and certainly efficiency, doing it quicker, capturing the regulations, and completeness is important. It may be aspirational, but we need to make sure that we get the coverage that makes automated compliance checking worthwhile. The interesting thing is that automated compliance checking generates better outcomes in terms of economics, environmental aspects, and social outcomes. And there's a paper that's cited there that makes the point that automated compliance checking is an important economic lever for governments to support, because it makes the control of the economy much more responsive. Construction is one of the major means by which governments manage the economy, manage growth, manage expenditure, of course, and anything that accelerates the process of going from an impetus to seeing those economic outcomes is very important. And the paper that I mentioned correlates the length of time that it takes to get approvals with the shortness of time with economic responsiveness. Of course, we also want to see better environmental outcomes, and the slew of various kinds of environmental assessments suggest that a systematic approach to submittals and assessment is going to be important. Earlier this week, I was studying the biodiversity requirements that have been formalized in the UK. It's reached the point now where the amount of information and the structuring of that information really would benefit from a model-based approach. And yes, social outcomes in the sense of the economic and environmental outcomes are intended to be of benefit to society. I also spoke about the regulatory information requirements, looking at regulations worldwide in the building sector. I mentioned structure and fire, energy and accessibility. Looking at those kinds of requirements and identifying what information is already likely to be in an IFC model. Can it be calculated from the geometry and relationships that IFC holds? Is it particular to a specific jurisdiction, or is it related to the procedures and steps that compliance goes through? And a last category of things that that won't be in the regulatory information requirements is if it relates to compliance or expectations to other clauses and standards and so on. We will offer a set of properties to represent those kinds of cross-links that are common in regulations. What that leads is what new information do we want to specify, and is there anything we need to add to the IFC, the buildingSMART standard information schema, or the majority, can we add them to the buildingSMART data dictionary, which is the repository for the flexibility and extensibility of the IFC schema. And lastly, should it be published as an IDS, which I've already described? Should we generate IDSs to encourage the use of those regulatory information requirements? I've mentioned IFC 4.3 a few times. As I say, it was accepted as an ISO standard, so it is now the ISO standard, and it is the current IFC schema. As I said, it covers railroad, bridges, ports and waterways. It also has improvements in lots of other areas, such as system monitoring and triggers, accuracy and uncertainty, geotechnical information. And rather than go into all that detail, I just wanted to highlight the organizations worldwide that have contributed to the specification of the extensions to IFC 4.3 and its deployment. And I think more and more it will be seen this year as being the IFC of choice. Maybe some of the participants will be familiar with IFC 2x3, which has been the preferred schema for almost 20 years, I think. Yes. This represents the next major step in making sure that the IFC is applicable to the built environment as a whole. one of the things that has surprised me, and many of us in the regulatory domain group, is that maybe 10 years ago, we presented this, or it was Masako Muto from Japan, who offered this stepwise progression towards automated construction permitting, looking at the manual process, and then saying that there will be some low-hanging fruits where regulators will accept IOC files as supplementary information, and then start to use it in a hybrid sense to check some things, to measure some things, to view things, all as a stepwise preparation to the introduction of fully automated compliance checking. This seemed like a plausible stepwise approach for both regulators and submitters. But actually the reality has been not so much the stepwise diagram in the middle there, labeled 3, but we're seeing, as I say, Dubai, Singapore, Finland, Estonia, taking the blue path of going for a direct and immediate implementation of automated compliance checking. In Finland, it's supported by, or it is being supported by legislation that makes IFC a requirement, not only for the regulatory process, but also for the National Mapping Authority and the National Archives. Similarly, in Dubai, although it doesn't apply to all building types, they've gone straight from manual process to requiring and applying automatic compliance checking. So it sounds like there is a pent-up expectation and demand to move towards automated compliance checking in the building sector, which most countries are aiming to meet. The reason that I think the building compliance process is relatively well understood. Here's a diagram with automatic compliance checking in the diamonds. And of course, we're talking about building information models. And in the bottom left-hand corner, we have building regulations. And we can use ACC to compare those building regulations against the building information model. If there is a failure, then the red path takes us to some virtual rework, and resubmission. In the Singapore system, 20 years ago, any designer could, in Singapore, could make a test submission and get the feedback and iterate around it until they knew that the building information model was compliant. And only then need they make the formal application with fees and so on. So the rework and development was intended to be incremental. Of course, if the automatic compliance checking generates a pass for the scheme, then we might well proceed to building on site. And then automatic compliance checking has a slightly different role, in the sense that we want to be able to validate what's happening on site against the building information model. so that any deviations from what was agreed can be detected. And of course, you may go back to checking against building regulations, but in the first instance, the checking process is making sure what's happening on site matches what was agreed in the building information model. Of course, if there are failures at that stage, then we could be talking about rework on site, which is a lot harder. So that process is reasonably well understood. In some countries, there is no supervision of building on site, but insurance and professional liabilities take over. Certainly in the UK, we have a system of inspections there. The thing that I think makes infrastructure and engineering interesting is that there's another possibility, and I think it really arises because in infrastructure, very often the client body is to a degree self-regulating. That national agencies are responsible for both the regulations and the production of schemes and delivery of schemes that are compliant to them. And that leads to an interesting variation that we can still expect to do automatic compliance checking, but if it reports a fail, we may choose, as before, to develop the engineering information model, but there is an alternative, which is that these agencies can develop a claim for an exception, and those exceptions may arise because of constraints or changes in engineering practice or other practicalities. And so there is often a mechanism of departures and derogations and exceptions. All these words get used, but you end up with a body of decisions which are outside of the engineering regulations, but represent precedent, or they may just be taken as one-off exceptions. And so there then has to be a process of thinking about how those exceptions get absorbed into the engineering regulations in a revision process. And I think that's any automated compliance checking is going to have to cope with, support, engage with these exceptions. People on the call who are familiar with English or American law will know that at a legal level, there's always a body of case law which effectively does the same thing and extends the laws with cases. And I think automated compliance checking is going to have to take that on board. These departures and make sure that the body of knowledge expands, or body of requirements expands to acknowledge these past cases. And then the same thing happens that once there is a pass and construction on site begins, there can be a continuous process of compliance checking of the agreed model against the reality. Okay. Okay. Sheila, I hesitate, but have we got a speaker?
Unfortunately, no. We don't have Ruben on the webinar, I'm afraid.
Oh, right. I apologize for this and the difficulties. I'm not sure what's caused them. I'm going to pause now and ask if anyone has any thoughts or questions, picking up on the points here. Please do use the chat to log them. Yes, Sheila's already confirmed that if there's a desire for any of these of the material, the recording will be published, and if they're needed, we can share the slides. So there's a I see some familiar names on the list. Yeah, so I'm hoping there'll be some further questions on this. I have to admit, my background is as a long time ago, it's as an architect. So I'm really looking forward to learning about the aspects of compliance in the industry. Okay. Yes, so there's a question here to explain more about the IDS and how it connects to the ISO standard for information requirements. I think there are two ISO standards that are relevant to this question. The most prominent one is ISO 19650, and quite tricky to sum up the whole of ISO 19650. But one of the key points has been that the client body should organize or should include in the contract, in its appointments, I should say, information requirements. So alongside all the physical requirements and maybe process requirements as well, the appointing party, the client body, should express themselves about what information they need to receive from a project, or indeed need to maintain about an asset. And up until now, those information requirements have tended to be tabulated either in spreadsheets or in Word documents. And the challenge has been to make sure that those requirements are satisfied. And that has usually meant a degree of interpretation and translation of information requirements into something else. That translation process isn't the worst of it, in my view. The big challenge is that those information requirements have to be signed off inside the client body at a senior level in terms of strategic need. They need to be signed off by the management layer to make sure that the information requirements are organized in a way that is useful to the client body. And of course, there may be operational skills and knowledge that needs to be applied to those information requirements. And these schedules have tended to be quite hard to review and check on both sides of the contract or appointment. So there's been a perceived weakness, and what the one of the responses to that has been an extra ISO standard called ISO 12911, which gives a very structured way of laying out the strategic objectives, the management controls, and the specific information requirements in a way that is close to a rules-based layout. And indeed, if you lay out your requirements according to ISO 12911, you are well on your way to producing machine-readable, machine-operable formats. And what IDS does is to say that either from some other means or through an interface, you can set up the information requirements in a condensed way. One of the worst things I ever saw was a 2,000 sheet spreadsheet. Each sheet was devoted to one object type, element type, and each of those sheets then detailed all the information that was required about each. And of course, it was incredibly repetitive to the point where it was unmaintainable, that the changes and revisions completely overwhelmed the process of maintaining this document. IDS says that you can be much more concise about this, that you can define the applicability of your information requirement, and then you can define the needs. So you can say, you can make a list of electrical equipment and then say, well, any kind of electrical equipment, we require the wattage and the phasing and the power outputs and so on and so forth, voltage and so on. And so it should be possible to have reasonably concise information requirements that are that can be reviewed at each level of an organization, both on the client side and on the appointment side. And the document can, of course, be attached to a contract if necessary. And there are tools, some of them free and online, to allow you to systematically check the information deliverables, the models, against an IDS file. The kinds of things you can specify in an IDS are oh, there we go. You can either on the select or the applicability side and on the requirement side, you can say things about types of object, you can say things about classification, about material, you can say things about direct attributes, and indeed about relationships. So it takes the idea of level of information need and focuses on the information content. As yet, it doesn't say anything about the development of shape and geometry, and it doesn't say anything about the requirement for supporting documents. So, so I think it's an implementation of the information requirements ID, which actually makes it makes 9650 a much more tighter set of contracts and appointments. There's a question here saying that some organizations are hesitating to use IFC 4.3. Okay, so my pitch for IFC 4.3 is that it is simpler. Even in a building context, there's been a process of rationalization of the IFC schema, and in particular, every entity that you might place into a building or a piece of infrastructure has a matching type entity where you might store the specification, or indeed the manufacturer model number that's been selected and so on. So in general, it's easier to map, whether it's your Revit or ArchiCAD or Tekla classes, to IFC 4.3. There's no need to worry about IFC flow terminal anymore. You can talk about IFC sanitary fitting instead, or light fitting, or whatever it happens to be. The other really positive thing for the whole industry is the inclusion of site and outdoor features, landscape, geotechnical information, and so yeah, its ability to apply the context, which of course is very much part of project and asset management. The area of complexity in 4.3 is the fact that infrastructure has less clear spatial structure. Now, the spatial structure is a kind of organizing skeleton, and in a building, it's very clear. That and by culture and convention, we can be reasonably happy to talk about site, building story, and spaces as being the spatial structure that we use to understand and experience buildings. In infrastructure, it's not quite so clear. There undoubtedly is a spatial structure underlying infrastructure projects, but it may be thought of in terms of sites and regions. It may be understood in terms of, instead of building stories, which are vertically stacked, the spatial structure may include dividing linear infrastructure into segments lengthwise, or indeed dividing it into segments laterally, so that you have the cutting or embankment, and then you have the drainage, and then you have the hard shoulder zone, and then the carriageway zone, etc. And so there may be a spatial structure about the linear shape, the cross-sectional shape, and so on, and as illustrated in 19650. So that needs to be set up, and I think most of the authoring tools are struggling to give the right interface that people can choose the spatial structure appropriate to the infrastructure. Okay. More generally, I think there's a question about what are the challenges of infrastructure compliance. I'm keen to learn, and I think this issue of departures and derogations and exceptions, I think, is a major significance. Also, that many organizations struggle to separate the regulations, which will have the word shall in them, with the clauses that are suggestive and say should or indeed can and may appear, and so on. So that sometimes they lack the requirements documents lack the rigor that we see in building regulations. Now that doesn't make it impossible, but it means that the automated compliance checking has to be more subtle. Right. Yeah, some encouragement for IFC 4. I think most of the software vendors have got an IFC 4.3 policy. Many were waiting for the ISO acceptance, and that was delayed by perhaps 6 months last year, mainly for improvements of the documentation. And the IFC 4.3 documentation is certainly of a higher standard than in past releases. Yeah. So now someone else has answered the question. So yeah, there's some points been made that infrastructure compliance checking may be trickier than similar checks on buildings. Well, that's really the interesting question. Road geometry or required visibility might be require different approaches than in buildings. Yeah, I mean, I think the aspects of infrastructure such as alignment curves, both rail and road, and to a lesser extent canals, use an alignment curve as the basis of the development of infrastructure schemes. They follow slightly different rules in road and in rail, and indeed across the world, there is a huge number of different allowable geometries that, if you think back to the earliest days, it was perfectly acceptable to have flat roads and simple circular curves on roads and railways. With increasing speeds, it's various kinds of clothoid and parabolic curves have been introduced. So the geometry is more complex. And a lot of the work that went into IFC 4.3 has been to find common representations of all those different kinds of alignment curve. Infrastructure. Yeah, I mean, obviously checking simple information content is straightforward. The kinds of geometry that you get is well, it's rare to find these complex curves, either in 2D or 3D in buildings. So I think that's the thing. I mean, both buildings and infrastructure have ideas and requirements about visibility. And there's in buildings we have escape routes. In road and rail we have these visibility constraints. Of course, direct simulation has proved very valuable for things like certainly Crossrail in the UK, to have a final human factors check that the experience isn't too cluttered, but the geometry of visibility checks is going to be interesting. Okay. I think, yeah, so I'm reasonably confident that IFC 4.3 can represent any of the road and rail geometries in use around the world. Yes, and it can also be used to represent existing survey layouts, which is an important feature. You may not know what geometry was used to lay out a road or a railway in the past. Yes. Can I ask if there are any other thoughts on what we've covered today? The other area where I think there is scope to deploy IFC 4.3 is in the area of construction management and risk management. I think the developments that we've seen in the UK, it was called PAS 1192 Part 6. It'll shortly be ISO 19650 Part 6, which is about representing and communicating risk, is a major benefit of using these models is to create a collaborative environment, sharing geotechnical. I think the importance of sharing those 3D forms of what's known or is approximately known, sharing the uncertainty attached to those objects, sharing where trial pits have been cut, sharing where boreholes have been dug. I think this is all laying the groundwork for making the model extremely relevant during the construction stage, and then passing on the residual risks and of course the as-builts into asset management. And I think owners are starting to appreciate that the IFC is a safe way of securing their asset information over the long term, and that they can, in the same way as governments are recognizing that the IFC schema represents a secure repository for the built environment information. So, okay. I think at this point, unless there are any further questions, I will draw the meeting to a close. Thank you for attending. I apologize for our missing speaker. And just to say that after Valencia, the regulatory domain team are planning 2 extra open houses. One to talk about the guidance document once it's published and available, and one to talk about the regulatory information requirements. So yeah, do watch out for those. And last of all, if anyone wants to contribute to this, the infrastructure angle on compliance checking, the email is regulatory@buildingsmart.org, or you can get in touch with me or Sheila, but regulatory@buildingsmart.org is the way to go, because I really hope that we can form an interest group to take forward, well, to discover what the needs and requirements are, and then maybe to, well, yes, hopefully to follow that up with responses on how the buildingSMART open BIM standards can support that. Okay, so yeah, the email's in the chat there. This has been a joint effort by buildingSMART International and buildingSMART UK and Ireland, and the same message goes to the UK attendees, to say that very keen to take forward these issues at the UK level and make sure we get the engagement of the major client bodies and major supply side actors around NEMA and buildingSMART UKI. Yeah, but the email will work for either. And thank you for attending. Thank you for some interesting questions. And till next time, thank you. And thank you, Sheila, for the supporting activities.